In this video I'm going to take you through the entire process of animating and creating a sprite sheet out of those animations, and we're going to import the sprite sheet into Unity and use Sprite Manager to animate a sprite on the screen when we're playing our game. Alright, so there's quite a lot of things to do. So the first thing I'm going to do, I'm going to create the frames or the sprites themselves, and to do that I'm going to use Maya. So don't feel like you have to use Maya. I think 3D Package is an awesome way to create sprites. You can be as detailed as you like, and it's easy to animate using Maya and stuff. So but you could actually sketch sprites yourself. You could use another package. You could use Flash. In the previous video we talked about the SWF Sheet software package. You could use Photoshop to do your frame by frame animations. You could use anything to create sprites, guys, but I'm using Maya, so I'm just going to do a simple animation. So I'm going to just create polygon and a helix, because helix is a really cool shape, I'm just going to create a little one. Okay, I'm just going to assign a new material to it and give it a colour, a nice blue. So I've got a few shades of blue there, it's awesome colour. Alright, so that's all I wanted to do really. I don't want to mess about too much in Maya. So to animate this, let's go to our animation tab. Let's press the keyframe button and on frame 24 and make another keyframe, and I'm going to change the rotate Y to 360, and then when we scroll through our animation timeline we've got an animation. So that's what I'm going to do with the animation, guys, and I'm going to call it Helix Sprites. Okay. So now we need to render each of the frames into separate images before we create our sprite sheet. And to do that we can go to our render view, and the first thing I want to do is line this up because we have tons of white space at the moment. I'm going to render out a 128 by 128 sprite. We'll go through the sprite settings in a sec, but one of the golden rules when creating sprite sheets is that you don't want any white space because it's a waste of space. So let's just line this up. As it animates it might actually bleed out, so I'm going to zoom it out a bit actually. So yeah, that'd do, I think. A bit too much, so a tiny bit. To do this you hold the Alt key and then hold the right mouse button and drag, then you can zoom in on Maya. So let's just do it like this, and that'd do. Not too worried about white space in this example, but you get the point, guys. Let's go to options, render settings. There's a few things we need to change here. We need to change the image format because I don't think, well, Unity might support a Maya image, but I don't know. But PNG is good quality, it supports transparency, and Unity likes PNGs. Okay. The second thing is the frame animation extension, because the default one is the name then single frame, and this just exports the current frame we're on, so we can't export all of them, and the frame range is grayed out, so we need to change this to the name, hash, the hash and the extension, and then we can assign our frame range. So frame 1 to 24, that's absolutely fine. And if you go down even more, the width and the height 128 by 128. Okay, so I think this is big enough for my Unity example. Feel free to change it if you like, guys. So very, very good Maya for exporting your sprites. If you have very detailed sprites you can put as much detail as you like. Very, very flexible bit of software. Okay, so and another thing to mention, if you're creating a sprite sheet with 8 sprites per row, then it's a good choice to make a width and a height of 128, because 8 times 128 is 1024. So that's a really good thing. Once you port it into Unity, the texture will be supported in Unity. You won't have to resize it or anything. So okay, but anyway, that's all sorted out, and to render out this we need to go to our rendering and press batch render. This renders out the entire frames we've specified in our render options. Okay, guys, so boom, clicking the button, and now rendering with Maya software. That's cool. Now it's rendering out, it's thinking about it, and depending on how fast your computer is, this might take a while. So it should only take a couple of seconds. No point cutting the video because I think it won't take very long, but I might be wrong. Okay, here we go. So this is happening in the background. Maya's rendered all this out, saved it in our default directory, haven't changed the directory, and the rendering's completed. See console for more information. but I won't be doing that. I'm going to show you where it's stored. If we go to my documents, this is on the Mac, I don't know if it's the same on Windows. Go to Maya, Projects, Default, Images, boom, here's all our sprites. I'm just going to check they're all in the image, not clipped out, and that looks pretty good to me. Okay, that's cool. So if we hop over to our bit of software, I'm using Sprite Sheet Maker, totally free. You can also use other software packages, but I recommend a free package because at the end of the day we're just creating an image. In the previous video we used another one called SWF Sheet, which you can use to import Flash SWF files, and then it will separate the files, each of the frames, into a sprite sheet, and that's really cool. But in this case, Sprite Sheet Maker for Maya frames does the trick. So import images. Okay, let's go to our documents, Maya, projects, default, images. Okay, so as you can see, it's all numbered in the correct order. Open them out, and I'm just going to. You can add images by clicking them, but I'm going to add all the images straight away. And you can, if you wanted to, you can rearrange them and stuff. So that's really cool. Okay, I'm going to make the column count of 6. So like I mentioned earlier, if we've done 8, this would be 1024 pixels wide. And when we import it into Unity, we won't have to worry about resizing the texture. But you know, that's just a thought. I'm going to make this 6 by 4. So if we preview the sprites, we've got 6 columns, 4 rows. That's cool. I'm happy with that. There's a bit of white space. You might want to optimize the white space a bit if you want to, you know, cram in more sprites. But for this example, it's totally fine. And click Export Sprite Sheets. Let's go to our Unity project. I'm just going to import it right into Unity. And let's just go to Assets. I've made a new folder called Sprite Sheets, and I'm just going to call this one Sprite Sheet, and it's exporting as a PNG. Okay guys, so save this out. All done, don't need to do anything else here. Let's just quit the program. Right, let's go to Unity now. So this is our Sprite Sheet, we've finally got it. So we've done all our artwork, we've rendered out all the frames, and now we've created a Sprite Sheet. That's really awesome. We can now animate things in Unity. So the first thing we need to do here is create a material, so we can import it into our Sprite Manager. So material, I'm going to call it Sprite Sheet, and if we hop to the wiki for a sec, I'm going to just search something, particles. So it says here that it is strongly advised that for sprites who use one of the particle shaders, so that backface culling is not an issue. So that's what we're going to do in this video, and the one we're going to use is particles and alpha blended, because if we do alpha blended then the light doesn't react and stuff, and it's really cool. It doesn't react to the 3D space and that, so that's what's good about particles. And we just need to put in our sprite sheet. Try again, sprite sheet. So that's our material sorted out. Let's create some game objects. So we need to create an object for the Sprite Manager itself. So I'm going to say Sprite Manager, and we can either drag on the Sprite Manager script or the linked, but we're not going to move our sprites in this video, so I'm just going to drag on the Sprite Manager. Our material we just created called Sprite Sheet, that's cool. And we're going to allocate a block size of 1. I'm just going to do 1 sprite. This is explained in the wiki. Just allocates memory, so you don't have to keep reallocating memory for your sprites and stuff. So if you know how much sprites you're going to use, just allocate a block size. The plane, which coordinates is going to be drawn in, that's pretty simple. Winding, not important. Updates, not important. Okay. All of these things are explained on the wiki. All you need to do is search it, so wind. And it was just where we were to begin with. So, which way do you wind the generated polygons? Blah, 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 blah. This affects the direction the polygons are considered to be facing. If you can't see them in your scene, try the opposite way, then you probably will see them. Okay, guys. So let's just keep it counterclockwise. Okay, so that's our Sprite Manager object, and we need to zero this all out. Boom, because when we create the sprites are created, or the quads are drawn relative to our Sprite Manager. So if we zero this out, they'll be in the right position and we won't have to worry about it and stuff. So, and the scale's got to be 1 as well, because we don't want our sprites being massively huge or really small. Okay, and we draw all of our sprites on a client object. So we create another game object. It can be called anything you want, so I'm just going to call it client. Okay, so it's got a transform. I'm just going to hold, right, let's just line it up in the right place firstly. I'm going to put it around here. So I'm going to hold V and just drag it to this, snap it to this vertex on my game object and put it around here. Let's frame up on it. So this is where our animation is going to be played, and it'll probably be here in our game. Let's save this out. Okay, so in our script I'm just going to reference this client object. We might want to instantiate it in our game and use that as a client or a game object, but for this example I'm going to keep it simple. I'll go into a real world case in the next video. Okay, so I'm going to create a new script so we can manage all this called, let's call it world GUI, because I had the world GUI thing going on in my previous videos. That's why I'm going to call it GUI. Okay, so this is where we're going to code all our animation and our sprite and stuff from Sprite Manager, and to do that we need to refer to a Sprite Manager object in our game. So Sprite Manager, let's just call it Sprite Manager with a lowercase s, and if we go back to Unity I'm going to drag that in, but I'm going to make a prefab of it. So create prefab, let's call it Sprite Manager, drag this in here, and on our world GUI drag the Sprite Manager object in here. Okay guys? Okay, so now we can refer to the Sprite Manager. Okay, so I'm going to make a function to do all this stuff. I'm going to make a public void draw curl animation. I've just called it a curl because we're curling the helix in our animation. Simple as that really. Okay, the first thing we need to do is put the sprite on the client object. So we can just say game object client equals game object find client. We can instantiate game objects and stuff, but for this example I'm just going to do this. Okay, and I'm going to make the sprite. So we're going to type def it sprite. I'm going to call it client sprite because it's on the client object, equals Sprite Manager, referring to our Sprite Manager object, add sprite. Boom. Okay, so let's get to this, and here it is. The documentation's here. So this method will add a sprite to the Sprite Manager's list and will associate it with a specified game object, which is the client object. The sprite list is blah blah, has UV, blah blah blah. Okay, is that all I need to mention there? And that's these are the arguments. So the first one's the client. That's simple enough. We type in client really. The width and the height in world space units. Okay, let's just guess for now. I'm going to say 10 units in world space. That will probably be cool. Okay, the lower left coordinate of the quad. Alright, the lower left UV. So if we hop back to Unity, let's go to our Sprite Sheets folder. Sprite Sheet. I want the lower left UV to be here because I want this to be our sprite, this object here. Okay, this is going to be our sprite, the first sprite in our sprite sheet, and UV coordinates go from 0 to 1 and start in the bottom left. So 0 0, the Y goes up, the X goes across, and the maximum value is 1. So I guess the lower left UV will be 0 because we're going 0 across, and 0.75 up because 0.75 will be 3/4 the way up, and then we can reference the lower left UV of this sprite. Okay guys, really simple to do. If you don't know the UV coordinate, if it's 0.3335 whatever, Sprite Manager has two functions to convert pixel space relative to the Sprite Manager material to UV space. So you can be like, I know the pixel coordinate of that, but I don't know the UV coordinate. So you can pass in the pixel coordinate in these two functions. They explain how to do that. But in this case it's quite simple because well, I knew this was going to happen, so that's why I've done 6x4. So the next thing we need to do, just define a new vector 2 because UV space is a vector 2, an X and a Y, and like I said, we're not travelling anywhere across, so it'll be 0, and then we're going to go up 0.75 of the way, and we can just say 0f, 0.75f, and float values, and that's the lower left UV. Okay guys, what's next after that? The UV dimensions, the width and the height of how much the texture is to use. This is a scalar value. So if the lower left started at 0.5, and UVs were 0.5 as well, this would take up the entire texture to the top and the right edges. So pretty self-explanatory. So we can say new vector 2 again because it's a x and a y value. So let's have a look at this. We want it to go, so we've got 1, 2, 3, 4, 5, 6. So we want the UVs to go 1/6. We want the UVs to take up 1/6 of the space, and we want it to go up 1/4 of the space. Okay, so what's 1/6 of 1 basically? And this is where you might want to use these functions, the pixel to coordinate. But I know the value is 0.1666667, and that is 1/6 of 1. Okay, so 1 divided by 6. Alright guys, because we've got 6 sprites in a column and in a row, sorry. So, and we want to go 1/4 of the way up because one sprite takes up 1/4 of the sprite sheet. Okay, so that's really simple to do. 0.25. 1 divided by 4 is 0.25. So simple enough. Okay, what's next? The offset. The sprite will be offset to the specified vector 3 relative to the client game object. Well, we don't want to offset it, so we just say vector 3, 0. I want it to appear right on top of my client object, so that's not really a problem. And the last one, billboarded, whether or not the sprite should be rendered so that it's always facing towards the camera. I'm going to put false, might take up overhead. And in my experimentations of this, it doesn't work very well anyway, so I'm going to put false. And that's our sprite, so that's cool. We've got a sprite, but we want it to animate. So I'm going to set up a new animation, so set up animation. And Sprite Manager has a separate class called UV animation. Where is it? Somewhere over here. So UV animation. Okay, here it is, the UV animation class. So we can define an animation's name, the loop cycles, whether it's going to loop, or we can define a set amount of time it's going to loop, whether we can loop reverse it, and the frame rate. So that's all we need to do for now. So let's do a new animation. UV animation, let's call it curl animation or anim, equals new UV animation. Boom, simple enough. Okay, so let's say curl anim.name, let's just call it curl animation. Okay, so let's say curl anim loop cycles equals, well, I want to repeat it indefinitely, so I'm going to put -1, so it explains it here. 0 is just a one shot, just does it once. Anything above that, 1 to 2 to 3, would loop it that amount of times. -1 loops indefinitely, so that's cool. Is there anything else I want to do? Just to be on the safe side, I'm going to say curl animation frame rate is 24 because we've got 24 frames and we want it to last 1 second, so that sets up our frame rate. Okay, and to build the animation we use another function called build UV anim. This method automatically builds a UV animation sequence from a few pieces of information, so it kind of automates the process of building an animation basically, and these are the arguments. So like we did for the sprite, I'm just going to go through that. Curl animation, okay, build the UVs, that's pretty cool, and we're going to do a new vector 2 firstly, which is the start, the UV coordinates of the lower left corner of the first sprite in the sequence. For this we can just say, well, it's the same as this one, the same as our starting sprite, so I'm just going to say the new vector 2 0f.75. Okay, so when our sprite's not playing an animation, it can refer to this sprite. If it is playing animation, we can then set up the animation, which we're doing now. So the first one's the vector 2, going to start in the same place, which is here. Now we need to define the cell size, so again it's going to be the same as this one here, new vector 2, that's going to be the cell size, and the rest of it's pretty self-explanatory. So the columns, the number of columns in animation, well, 1, 2, 3, 4, 5, 6, so 6. The number of rows, that's 4. And how many cells are in total? Well, there's 24 I think, 1, 2, 3, 4, 5, 6. Yeah, it's 24 because we're going to last 1 second. And the frames per second, so that's going to be 24 as well. Okay, so we've built the sprite, we've set up the animation. All we need to do now is prepare it for the screen to animate. Okay, so prepare sprite, we can say client sprite, we can add the animation to a sprite. Add animation, okay, the curl anim, that's the animation we just set up. And then we can also say client sprite play animation, because at the end of this function, once everything's set up, I want to play the animation. And we refer to the name, so curl animation. Okay, really handy stuff there. So did I spell it right? I think so, but just in case, I'm going to copy and paste just a thing I do, and that's all we need to do. So we don't need to call this every frame, because once the animations start playing, we don't need to update it every frame. So I'm going to call this in the start function's start method. So when the script first starts, we can say draw curl animation, and then we're done. Okay, so I think we're almost done here. We've set up our sprite, we added a sprite to it, we've also added the animation to it, and as soon as the animation's created, we want to add that animation to the sprite and play it straight away. So let's go back to Unity. I think everything's set up okay, and if we select our world object, we just need to drag on our world GUI script we just made, world GUI, and we want to replace this Sprite Manager prefab with the game object in the world, so we can actually refer to an object that's in the scene currently to manage the sprites. So I'm just going to drag this object onto here. Boom. Let's see if it works. Okay, it's working, that's awesome. So here we are in our scene, our animation's playing, and it's 2D. Okay, that's our animation playing on top of our client object. But if we look at it from this direction, it looks 3D. It looks awesome because we've made it in Maya. It's 3D animated, and it's repeating itself over and over again. So if we look in the actual game, it doesn't look that good. We haven't optimized it very well, but in the scene view, everything's working fine. And 10 units seems to be quite good. If we zoom right in, we can see that it's animating. If we zoom out, it looks pretty smooth. So that's it for this video, guys. In the next video, I'll do a real-world use case for this, maybe a loading screen or something. And I hope you've learned a lot in this video. I hope it's really helped you out. And that's how we use Sprite Manager within Unity, and the whole process of creating a sprite sheet and using Unity to make 2D games, or 2D objects in 3D games in this case. Thanks for watching the video, guys.